A beam with a rectangular cross section of 120 by 40 mm square is placed horizontally by mistake where as it was designed to be placed vertically. The reduction in load carrying capacity will be. Options are 1 by 2, 1 by 3, 1 by 4 and 1 by 6. Here the load carrying capacity of the beam is nothing but strength of the beam. Here strength of the beam is proportionate to the section modulus. Actually either load carrying capacity of the beam or strength of the beam is proportionate to the section modulus, that is generally denoted by Z. So let us say for take first case, so where it was placed vertically. So let us say if it is placed vertically, if it is placed vertically, ZV is given by 40 into 120 square by 6, that is BD square by 6. So which is equal to, let us say so it has some value, and consider second case if it was placed at horizontally, and for this case section modulus is given by 120 into 40 square by 6. So now take the ratio between these two, that is ZH by ZV, so that we get the reduction in load carrying capacity. So here ZH is 120 into 40 square, that is 120 into 40 into 40 by 40 into 120 into 120. Let us say it is 1/3. So the load carrying capacity will be reduced by 1/3 time. The correct option is B. A steel wire AB is stretched between the rigid supports. The initial pre-stress in the wire is 30 megapascal when the temperature is 20 degrees centigrade. At what temperature the stress in the wire becomes 0? Take coefficient of expansion is equal to 14 into 10 power minus 6 per degree centigrade, and Young's modulus of velocity is equal to 210 gigapascal. Here the the options are 9.8 degree centigrade, 10.2 degree centigrade, 30.2 degree centigrade and 0 degree centigrade. First, you have to read question again. A steel wire AB is stretched between rigid supports. So here stretching is nothing but it is elongated between the two supports. So here a steel wire AB is elongated between the two rigid supports, so that the initial pre-stress is 30 megapascal. So to relieve this stress, you will have to increase the temperature of the air, temperature of the wire. So to release the stress, you will have to increase the temperature of the wire, so that the stress will be released in the wire. So we know that the thermal stress is given by sigma is equal to E alpha delta T. Here sigma is stress in the wire or stress developed in the wire, where E is the Young's modulus of elasticity of the material, alpha is the coefficient of expansion of the material, and delta T is the change in temperature. So here the pre-stress is given by 30 megapascal, and Young's modulus of velocity is 210 into 10 cube Newton per mm square into alpha is 14 into 10 power minus 6 per degree centigrade, into here we will have to find out the increased temperature, so that it is T minus the initial temperature is 20. So on the solving of this equation, we get T is equal 30.2 degrees centigrade, and the correct answer is C. In an epicyclic gate train, an arm carries two gears A and B having 36 and 45 teeth respectively. If the arm rotates at 150 rpm anti-clockwise direction about the center of gear A, which is fixed, then the speed of gear B in rpm is. Options are 150, 510, 270, 300. Coming to the solution, first draw an epicyclic gate train which forms with A and B gears. let us say a arm connects between these two gears, and this is the gear A and this is the gear B. It is having teeth of 36 and B is having teeth of 45. Here TA having 36. So by using tabular method, here consider tabular method for epicyclic gear train. Let us say, let us divide this table in three columns. One is action and another one for revolutions of arm, rotations, and revolutions of A and revolutions of B. Okay, first consider arm is fixed, and let us say all rotates at plus 1 revolution. So here arm is fixed so that it is 0 and revolutions of A is, it is plus 1 and revolution of B is 1 into minus TA by TB, that is minus 36 by 45. So here the final one is minus 36 by 45. Now consider again arm is fixed and A revolution at plus x revolutions. So let us say this is s plus x and this is s plus 1. Here again arm is fixed so that it is 0 and it is plus x and it is minus 36 by 45 into x. So now add y revolutions to each one. So here this is plus y and here it is x plus y and here it is y minus 36 by 45 into x. So these are the final speed of the gear A and gear B as well as arm. So here in the question we have, if the arm rotates at 150 rpm anti-clockwise direction, that means the rotations of arm is given by 150 rpm anti-clockwise. So anti-clockwise is represented by negative sign. So here it is y is equal 1 minus 150 rpm, and we'll have to find out here revolutions of B, and we know that here A is fixed so that x plus y is equal 0. So but we know that y here, that is minus 150 rpm, so that x is equal to 150 rpm clockwise direction. So now the revolutions of B, that is speed of B, is given by y minus 36 by 45 into x, where y is the minus 150 and it is minus 36 45 into 150. So which is equal to, it is equal to 270 rpm in anti-clockwise direction. So but here the question is just the speed of gear B in rpm is. So here he didn't ask about either it is counterclockwise or clockwise. So the answer is just 270 rpm and the option is C.